Hello, so the inspiration for this video comes in two parts. One is that the New York Times released a list called the best books of the 21st century. And two is that YouTuber Lena Norms made her own version of this list where she ranks her favorite book that came out each year of the 21st century. Kind of inspired by that, I wanted to do the same, but for a topic that I'm really passionate about, which is science YouTube videos. That's quite specific and a bit of an ambitious title given that YouTube hasn't been around that long and in fact was only launched in 2005, but I've managed to go through and find one science video released each year since 2005 up until now that I would put on the list of my favorites. Now this is a very subjective list and this is the list of my favorite YouTube videos, no one else's, and I'm sure there'll be heaps of different interpretations of what belongs on this list. So I encourage you to leave a comment down below with your own list of your favorite science videos, but these are the ones that I settled on, and it wasn't easy. I had a huge list of highly commended videos that I would have loved to include, but I just couldn't find a spot for. And so these are videos that made an impact on me at the time that they came out or at the time that I watched them. They're not necessarily objectively the best or most polished videos, but for some reason I remembered them or they inspired me in some weird way. I apologize that there is quite a bias towards physics and math videos, but I think that just represents that I predominantly watch that genre of videos. But again, if you leave a comment and shout out your favorite videos that I've missed, I'll find that super helpful and I might find some new videos as well as everyone else who's reading the comments. I've got to admit the first few years were pretty slim pickings. There weren't a lot of videos around in those early years of YouTube at all. If you were on the platform, then you were setting a trend, and so there's not many science videos that I could find. But despite that, the first featured video is from 2005 and it is the famous first video ever uploaded to YouTube, me at the zoo. Now, despite only being 19 seconds long, this video I'm qualifying as a science video because he does give a fact about the elephants behind him. He says something like, "I'm at the zoo, there's elephants behind me and they have really long trunks." And so in that way, it is almost an explainer video. This video was uploaded by Jord, who was one of the co-founders of YouTube. And I rewatched the video today before filming this, and I was surprised to find that the description of this video had been recently updated. In fact, it was just a link to a video from 2024. And I was like, strange, check that out. The video it linked to was called 10 miles per hour versus Mach 10 airplane flyby, which seemingly has nothing to do with this guy or this video. The description of that airplane flyby video says, "If you're here from the me at the zoo video, then I'm just as confused as you are." And apparently Jord sometimes updates this description to criticize what's going on with YouTube. He used it to criticize the Google Plus debacle, and then recently when YouTube got rid of the dislike button. So it's this weird and very specific place where one person can get their thoughts out in a transient manner based on what they most want to say at any given time and know that there's this steady flow of traffic coming to look at it. A strange thing to find. I wonder what the description will point to when this video comes out. The next year, 2006, was unfortunately even slimmer pickings, but I bring to you Bubblegum Math. It's a Sesame Street animation uploaded by a user called Tiny Dancer. Look, the premise is very simple. There's a gumball machine with 11 gumballs in it. They remove 4 of them and then there are 7 left. And then of these 4, they remove 1, 2, 3, 4. And they have no gumballs left. The narrator is quite mesmerizing. I don't know if the millions of views that this video has are mostly from kids watching this or if it has become kind of its own meme, but that is the best science-related video I could find from 2006. 2007 brought us Carnivorous Plants by BBC Studios. This is a clip from a David Attenborough show called The Secret Life of Plants, and it's just a few minutes of Attenborough calmly walking around these very vicious plants. He stops by one of them and notes that it's so large that once the body of a drowned rat was found inside of it, which I found very creepy. And then he gives a nice calm explanation of these particular carnivorous plants, how they are filled with sweet nectar to attract insects and little animals, and then it has slippery sides so that creature will fall in, and it has toxic juices inside that will dissolve that creature's body. I think maybe BBC were slightly ahead of the curve putting this on YouTube in 2007 because it does have millions of views. And again, there wasn't a lot of other science content I could find. 2008, we got the first videos from Brady Haran, and the first kind of glimpse at the empire of science videos that he would be behind creating. This is the first proper video on the periodic videos channel where they go through each element from the periodic table one by one and mention some facts about it. This one was about hydrogen. They talk about some of the isotopes of hydrogen, like deuterium and tritium, and then they do an explosion where they have a balloon filled with hydrogen and they set it on fire. This is Martin Polyakov, who would become an iconic face on the channel with the Mad Professor vibes. And whilst this video itself was pretty simple, in fact they remade it a year later to be a little bit bigger and better, I think it's important to mark when Brady's work started showing up on YouTube because I feel like I've been watching it here and there ever since. He's covered maths and computer science and chemistry and physics, all in such a creative way. Not only was he ahead of the curve in 2008 starting this series, but even today his videos are still pushing the limits of what education means on YouTube and what it can be. My pick for 2009 is a song, part of the Symphony of Science series by Melody Sheep, and it is Carl Sagan, A Glorious Dawn, featuring Stephen Hawking. It's a remix of two science shows, Cosmos by Carl Sagan and The Universe by Stephen Hawking, but it's put together so well to become a weirdly catchy tune. Its chorus goes, "A still more glorious dawn awaits, not a sunrise, but a galaxy rise. A morning filled with 400 billion suns, the rising of the Milky Way." And it features iconic lines such as, "If you wish to make an apple pie from scratch, you must first invent the universe." It slays, it was very popular, I remember it, and I think it's an iconic member of the science YouTube genre. 2010, we have another song, believe it or not. It is Strange Charm from the Vlogbrothers. Specifically, it's one of Hank's videos where he sings a song that he's written about quarks. It features lines such as, "Up, down, strange charm, top, bottom. If you don't know what a quark is, it don't matter, you still got him." And it's very possible that this was my first time learning about quarks. Maybe now there's a lot more in the genre of nerdy songs about science things, but back in 2010 this felt revolutionary to me. This is also a reminder that Hank Green has been doing science on YouTube for a long time. The Vlogbrothers have been running since 2007, and Hank was making videos like this and some other science explainers on the Vlogbrothers channel before the launch of SciShow and Crash Course, way before TikTok and YouTube Shorts, and so much of the other things that he's gone on to do. And I think it's important to include at least one thing from Hank Green on this list, given his huge positive impact on science YouTube as a whole, as a genre, in all the many ways that he has been involved since making this video. We are now getting to some heavy hitters because this next one from 2011 is super influential and is definitely in the running for a greatest science video of all time, according to me. It is Outside In, made by the Geometry Center, but uploaded by a channel called SSGELM. I'm not sure if they had the rights to post it or what, so I'm going to link also to a remastered version endorsed by one of the creators of this show. Now, Outside In asks the question, can you turn a sphere inside out? It has millions and millions of views, and I know that this video has single-handedly inspired so many people to take a double look at the field of mathematics and to consider what math actually is, to realize it's about asking fun questions like this and playing around with weird imaginary stuff. This was my first introduction to this kind of topology and the idea that turning a sphere inside out was somehow a mathematical process. You don't need to be a mathematician to enjoy this video though. Its impact goes far beyond just getting people interested in maths. It is just so iconic. It starts with the line, "Hey, I read somewhere that mathematicians can turn a sphere inside out." and then goes on an explanation of how this is actually possible. I'll try to summarize it. You have a sphere that's made out of a material that can pass through itself, but you can't tear it or crease it, so you can't have sharp corners. It seems impossible that you'd be able to turn this inside out, especially given the fact if you just have a circle of the same material, you actually can't turn it inside out. They talk about something called a turning number, which is essentially the number of smiles that you can see in the shape minus the number of frowns, and that gives you your turning number. And for one shape to be turned into another shape, they have to have the same turning number. A circle and its inside-out version don't have the same turning number, but a sphere and an inside-out sphere do, so we know that it's mathematically possible. The secret is adding wrinkles to the shape to avoid sharp bends. So you take a wrinkled sphere and the caps pass through each other to the other sides and then start to rotate, twisting the rest of it in these strange ways. It does a bit of this, and then it's inside out. I can't explain it to you. The animation can barely explain it to you, but I can tell you that this video made a lasting impact on me. It made me love mathematics, even though I didn't and still don't really understand the full complexity of this problem. It's something actually that I'd love to dive deeper into. All I can say is that I love the way that this video made math feel weird. My pick for 2012 is Scale of the Universe 2 by Carrie K.H. This is really a video immortalizing the website Scale of the Universe, which is an interactive way to explore the scale of all known things. In this video, Carrie starts at the human scale, then zooms all the way in, past subatomic particles all the way to the Planck length, then zooms back out to the human scale and keeps zooming out, past the planets and the galaxies and the galaxy groups, all the way out to the size of the observable universe. It was made by Carrie and his brother Michael when they were 14 years old, and it's an awesome and fun tool that you can still play around with. I think what makes it my pick for 2012 is not just that it shows off some of the cool science, but that it has that lingering philosophical question to it. Why is it that the human scale seems to be roughly in the middle of these two extremes? And it's a question interesting enough to linger in your mind even after you've finished zooming in and out of all the fun things there are to see. Now you might think this next pick is a bit of an oddball, but for 2013 I've got True Facts About the Tarsier. This is from Zay Frank's True Facts series, which did really take over the platform in 2013, so it's fair to mention something from that series. But tell me why I was absolutely obsessed with this video as a teenager. There's a line in it saying, if you challenged a tarsier to a staring contest, it wouldn't understand a word you said. And I know that was definitely my Facebook status at some point. I don't know why, but I loved every image shown in this video and the way that he talks about the facts. To be honest, there isn't a lot of facts in this video. Some of the facts that are there is that the tarsier has the largest eyes in proportion to its body for any mammal, and each eye is larger than its brain, which, as Zay Frank says, is probably the reason why it hasn't invented anything. I do weirdly remember that I used to send photos of tarsiers to people if they messaged me on Facebook, and maybe I should go back to that as a means of communication. Another iconic fact from this video is that a one-day-old tarsier can climb a tree, whereas a human baby of the same age can do nothing. My pick for 2014 goes to Vi Hart with her anti-pie rant released on Pi Day. Vi Hart is an iconic math creator, and one popular tradition that she started was to release videos on Pi Day, not joining in with everybody else celebrating pi, but being someone to give it a little bit of criticism. This series of criticizing pi together form an iconic and very educational perspective on pi and its influence on mathematics. It is through one of these videos from Vi Hart that I first learned about tau, which is equivalent to 2 pi and is perhaps more useful than pi in a lot of instances. In this particular 2014 installment, Vi talks about how Pi is not infinite, it just has an infinite number of digits, but that is not as special as it sounds, and in fact numbers like 1/3 also have just as many digits as pi. 1/3 is 0.33333333 recurring. It also has an infinite number of digits. She talks about how yes, pi is irrational, and that's pretty cool, but being irrational is hardly rare for a number. In fact, there are many more irrational numbers than there are rational ones. It's the rational numbers, the ones that can be described perfectly as ratios between integers, that are the weird and special ones. And she also points out that yeah, it seems pretty cool to get an irrational number from what seems like a very simple geometry problem. You know, what is the relationship between the diameter of a circle and its circumference? But actually the other basic geometrical relationships between shapes such as the square or the pentagon or the triangle also result in irrational values. So thank you to Weihart for reminding us that whilst pi is really cool, no number is above criticism. Now, 2015 was the most competitive year. I changed my pick several times because there were so many great contenders from this year. I don't know what was in the water, but 2015, some absolute bangers. I did eventually settle on the Backwards Brain Bicycle by Smarter Every Day. This again is an absolutely iconic science video. If you haven't seen it, what Destin does is he acquires a bike that is backwards. When you turn one way, the wheel goes the other way. It's one simple change made to the bike, but the impact of that change is so interesting. In the video, Destin shows that everyone who has a turn riding this bike fails. Everyone feels like they'd be able to do it, but when they get a turn, they can barely ride more than a meter or so before falling over. And Destin says in the video that from this, he learned that knowledge is not equal to understanding. You might know how the bike is different and know what you need to do to ride it, but that doesn't mean you understand what the consequences really are and how to use it. Destin makes it his goal to actually master the backwards bike and be able to ride it. And after 8 months of trying, he eventually was able to do so. That is really impressive because I imagine that he didn't even know if that hard work would pay off. He could have quit and said it was impossible to ever learn the bike, but he must have known that if he just kept trying, one day his brain would click into place. And that's what he described it feeling like, that there was a shift in the way his brain was working. So he manages to ride the bike, and so does his son, who actually learned it a lot faster in just 2 weeks, perhaps because of the improved neuroplasticity of a child's brain. But learning to ride the bike isn't the end of this story. It's only halfway, because then Destin is in Amsterdam and he tries to ride a normal bike again, but fails. He can't ride a normal bike because he has retrained his brain using the backwards one. And there's a really great scene where he's trying and failing to ride a bike in public, being watched by all these Dutch locals who are probably judging this clueless American who doesn't know how to ride a bike. But as Destin says, that's not his problem. He's actually 2 layers deep. In just 20 minutes though, his brain re-clicks into the old way of thinking and he's able to ride a normal bike again. This video is great. It spans engineering, physics, psychology, a little bit of philosophy as well, and it's just a well-told story. In 2016, Veritasium gave us Is This What Quantum Mechanics Looks Like?, which I found to be a really interesting video, and at the time that I watched this did make an impact on me in terms of increasing my inspiration to learn more about this topic and just giving me a real nugget of curiosity to think about. In the video, Derek has a speaker that is vibrating oil, and then he makes a droplet which actually bounces around on the surface of that oil. The droplet creates and interacts with its own wave, and for example, if it lands near the front of the wave, the new wave will push it forwards a little bit, and in this way the particle will walk across the surface of the oil. It's not a quantum system, but it's a really powerful physics demonstration of what some of the ideas are behind quantum mechanics. It's called the pilot wave theory, and Derek shows how it creates something similar to the double slit interference pattern, but also if the droplet encounters a thin enough wall, it might be able to jump over over it in a similar way to quantum tunneling. And these pilot waves also give something similar to the probability distribution for a quantum particle, the probability of finding it within a certain region. I think this video was really impactful for me because I hadn't heard about the pilot wave theory before this, or I hadn't internalized that it could be so strikingly visual. Derek says in the video that De Broglie had proposed that light was these particles that had waves associated with them, guiding their motion, but I don't believe that this is a commonly useful description of light, and it's been overtaken by the Copenhagen interpretation of quantum mechanics with wave functions and collapsing of those wave functions when you measure a quantum particle. All in all, I just found it a really thought-provoking video. There's got to be at least one video from 3 Blue 1 Brown in here, and I've chosen to feature his 2017 video called Fractals Are Typically Not Self-Similar. In it, Grant talks about what fractals really are. Often fractals are shown off as just these self-repeating shapes, but actually a fractal is anything that has detail at every scale. So if you zoom in on a fractal, you don't necessarily see a copy of the larger shape, but you do see a kind of roughness. And that roughness is hard to measure and quantify, which led to the mathematics of fractals, spearheaded by Benoit Mandelbrot. One of the first problems he looked at was how to measure a coastline, given that if you use a different sized ruler, you'd get a different answer. There doesn't seem to be a true length of the coastline. People came up with ways to quantify this problem, and it is through something called a fractional dimension. Integer dimensions 1, 2, 3, for example, describe the smooth and easy to measure shapes, but the coastline of Britain turns out to be 1.2 dimensional. It's something more than a one-dimensional line, but not quite filling a two-dimensional plane. And what a fractal really is something with a non-integer dimension. There is a line in the video where Grant acknowledges that these fractional dimensions are of course made up, but that doesn't mean they're not useful, and points out that actually that's pretty much what math is. Unless you happen to be working on an applied math problem, then all of the shapes and geometries and things that you're working with are imaginary. Math is a place to play with relationships. They don't have to be describing something physical. In this case though, fractals end up doing a great job at describing nature, because nature is something that is inherently rough and fractal-like. My 2018 pick comes from Up an Atom, and it's What is the Schrödinger equation exactly? In it, Jade takes a fun and accessible look at the Schrödinger equation and describes it as being the F equals ma of the quantum world, and talks through how we can tease out the energy levels and the wave function of a quantum particle from this equation. When she talks about how the wave function is the probability of where a quantum particle is likely to be, she comes up with this analogy of a kid in their bedroom where there's an 80% chance you'll find them on the PlayStation, a 19% chance you'll find them in bed, and a 1% chance you'll find them studying. And that's the kind of information we want to get about our quantum particle. In 2019, I enjoyed this video from Physics Girl about antimatter at CERN. It's called Why This Stuff Costs $2,700 trillion per gram. Now my heart breaks for Diana, as she is currently suffering from severe long COVID and is unable to make videos. I encourage you to support Diana on her Patreon, where she does give updates about things she's trying and sometimes small amounts of progress that is made, but it's a really tough situation that she's going through. I'm sending my love to Diana and anyone else out there suffering from ME/CFS. You all deserve more research into this disease, as well as more support and more awareness and understanding from the public about what you're going through. In Diana's antimatter video, she talks about how it is the rarest substance in the world and the most expensive material in the world to make. She's at CERN in Switzerland, which you might know for its giant particle accelerator and the Large Hadron Collider, but off on the side of the accelerator is actually a decelerator, which takes antimatter particles that are created in those high energy collisions and actually decelerates them so that they can be studied and potentially collected, although I think that the amount of antimatter they're able to make here is very, very minuscule. After all, as Diana says in the video, 1 teaspoon of antimatter, if it was to annihilate with normal matter, would be enough to destroy the entirety of Manhattan. And in this video, we also get to hear a little bit about the story of how antimatter was theoretically predicted, that there was a negative solution that popped out of an equation that Paul Dirac was working on, and instead of discarding that negative solution as being non-physical, he kept it around, and eventually we realized it described antimatter, that there is such a thing as an electron with an opposite charge, that being the antimatter particle called the positron. Because antimatter is such a frequent guest in sci-fi stories, I think it's great that we were able to see the behind the scenes of a real antimatter factory in this video. In 2020 we got Minecraft but on a quantum computer by Jabrils, which I think is a perfect blend of game design, computer science and physics. In it, Jabrils is working with IBM's Qiskit, which is a way to write programs for quantum computers, but his problem starts with wanting to procedurally generate worlds for a game similar to Minecraft. He isn't happy with the simplicity of Minecraft worlds and wants a way to generate more complex terrain, such as houses built into hills, and the way he goes about this is to use something called the wave function collapse algorithm. Essentially, the entire map is in a superposition of states. States are things that spot on the map could be. For example, grass or dirt or water. If you apply some rules to those states, such as this state needs to have this other kind of state next to it or above it or below it, then from, I think, a random seed, you can collapse this wave function of the states into an interesting and unique map. Jabril writes the code to do this and actually does generate a bunch of interesting maps, but they're done on a classical computer, and he admits they take from 2 to 11 hours to generate, which is way too long to be practical for actually playing a game. And so he kind of identifies what seems like a cool use for an actual quantum computer, that if you really have this wave function of states on your game and you need to collapse the wave function, then perhaps that is something that a quantum computer would actually be well suited for, and would be able to give you the speed up in times doing it in just a few seconds rather than the hours that it's taking on the classical computer, which isn't designed with wave functions in mind. And so Jabril goes out and tries to convert his classical code into code for a quantum computer, but he faces how difficult that task really is. And so even though Jabril didn't get this code working by the end of the video, it's still a really valuable video for the way that it points out what a quantum computer might actually be able to do, and by showing some of his attempts to convert that code. My 2021 pick has a bit of a weird story. It is from Kurzgesagt, and it is called The True Limits of Humanity. Now this video is actually a remake of the same video from 2016, and it was watching it in 2016 that it first inspired me. But the team remade the video because there was a mistake with the original one. That mistake is that they had said it was impossible for us to leave the local group of galaxies that we live in, but in fact it is not physically impossible to do so, just extremely unlikely. But both versions of this video ask and answer the same question, which is, how far can humans go, and is there some kind of cosmic limit that we'll never be able to cross? The answer being yes, and I find this idea just so interesting, which is why I've put it on here as one of my favorite videos. The video says that we live at the tail end of star formation, and that the stars are kind of like an aging population. There are not that many new ones being born, but lots that are on their way to aging out of existence. And that is just one of the reasons that the night sky won't always look the way it does now. Another is that our galaxy, the Milky Way, is expected to one day merge with our closest neighboring galaxy, Andromeda, and together we'll make something new called Milkdromeda, with all of our stars mixed up in each other. So that's going to be our new local neighborhood, but everything else is moving away from us. the expansion of the universe is accelerating. So the distances between our galaxy group and the other galaxy groups is increasing at an accelerating rate. And there is a horizon where beyond that, everything is moving away from us faster relative to us than the speed of light. So even if we traveled at near the speed of light, we'd never be able to reach those places. And according to the video, 94% of the galaxies that we can see have already passed that horizon. The reason that we can see these galaxies at all is that we are looking at old light. When our telescopes look at these galaxies, we are looking at light that was emitted by the galaxy before it crossed over that horizon, and the light that it emits now will never actually reach us. There is a relatively small window of time where we can leave Milkdromeda or our local group and get to another local group of galaxies, spreading out our humanity before it's too late, because if we miss that window to jump to the other galaxy groups, then they too will move outside of our horizon. And the video finishes by thinking about a distant future alien or maybe human born in our galaxy that thinks our galaxy is the only one in the universe, because every other galaxy will have moved past that horizon. One of the last lines is very poetic, and it says that Milkdromeda may become an island in the darkness. I think the video is a great mix of astronomy and existential dread, so that's why it gets a spot on my list. 2022, my pick is I did the double slit experiment at home by Looking Glass Universe. Now this is another quantum mechanics video, a topic that is pretty popular on YouTube, but I think this one offers a unique perspective. And it's part of a series showing that you can do relatively simple experiments at home to demonstrate ideas from quantum physics. She starts by shining a laser onto a single strand of hair, which is a way to create the double slit interference pattern. And it's surprising enough to see that you can generate this interference pattern pretty easily, and that you don't just get a single dot with a line through it on the wall. But then the video goes on to explore a bit more the idea of whether light is a particle or a wave, and Mithuna says it doesn't really make sense to ask that question because light is its own thing, and mentions how it can be quite tempting to think of light as a particle and this whole wave thing as being more of a calculation aid rather than a physical manifestation. And so to see if she can visualize it a bit more, Mithuna goes out and gets a smoke machine and a better laser pointer, and is able to see a lot more of the experiment by doing this. She can trace back the light in the interference pattern to see exactly how it gets there, and sees that the double slit doesn't just split the light into two, it splits it into many beams. With this visualization, she's able to see that the waves are real. They aren't just a calculation aid. There is something about the light that is inherently wave-like in its nature. This isn't a groundbreaking or new experiment, but it is something that most people don't realize they can do themselves. Quantum physics feels so advanced, and some of it is, but there are fundamental parts of it that you can actually play around with yourself. You don't need to be able to understand all of the mathematics to be able to enjoy the wonder of seeing light behave in this way. 2023, we have this video from Answer in Progress called I Memorized 3,141 digits of pi to prove a point. Sabrina starts off with an experience that I related to, which is this fear that you are forgetting your own life. And she goes on a journey alongside memory champion Nelson Dallas to learn some memorization techniques so that she can remember her life better through the challenge of remembering a bunch of digits of pi. She learns that the most important part of being able to remember something is having a retrieval cue. And if you make these retrieval cues quite different and out there, then they will become more useful. So she dives into the idea of the memory palace, where you store unforgettable retrieval cues all around a map of what might be a physical space. And then in your mind, you walk through that space, seeing all of these weird and wonderful retrieval cues that help you pull back the things that you're trying to remember. Specifically, she uses the PAO system, person, action, object. And what she does is remembers chunks of 6 digits of pi at a time. Each of the 10 digits is assigned to a letter. And so in those chunks of pie she's remembering, the first 2 digits will be 2 letters, and that will describe a person. So maybe that's the person's initials, or maybe those 2 letters sound like someone's name, but then that person will be doing an action described by the next 2 digits of pi, which are the next 2 letters. And that person doing that action will also have an object with them, which is described by the last 2 digits in the chunk, translated to the last 2 letters of the chunk. Sabrina uses code to do this conversion between the digits and the letters, and then places these weird images into some memory palaces that she can walk through in her mind. It takes her 3 weeks, but she manages to remember the thousands of digits of pi and actually performs reciting them in a cinema. Things get chaotic and it becomes a memorable experience, but she concludes that it's these little cues that can help you remember big things. I think it's such a well-made video with great storytelling and great visuals, and something that makes me feel inspired when I watch it. 2024 is not over yet, but I would like to submit this video as my front runner. It's by Tom Lum and it's called You Are Made of Hourglasses That Fall from the Sky. It's about carbon dating, but it also feels like the movie Everything Everywhere All at Once, and it features a cameo by Hank Green and another cameo by My Pencil, and it just covers all these different aspects of science in a really artistic and humorous way. Tom is asking the question, how can we measure the passage of time, and points out how remarkable it is that these tiny hourglasses in the form of radioactive nuclei happen to be inside of us in the form of carbon-14. I think even if you know about carbon dating, you won't know every aspect of this story. Now that would be the end of the video if I hadn't saved one spot on my wall of favorite videos. This is after all my list and I get to make the rules. There is one creator who could have conceivably won many of the recent categories, so I moved them to their own category at the end of the video, and that is for Vsauce. Vsauce has made many of my favorite videos, but to just pick one to shout out, I've chosen Messages for the Future, which is from 2015. It is not the highest effort or most groundbreaking video from Vsauce by any means, but it has a special place in my heart, I think because of just how it happened to inspire me back in 2015. The premise of the video is considering that the Earth, or maybe even humanity itself, may be wiped out. And in potentially preparing for that, how could we send messages to the future to perhaps be discovered by alien civilizations, or to at least leave a mark of what we were and what we knew? There's the Arecibo message that we've already sent out, as well as our TV and radio signals, which will make it some distance away from Earth. But then there's also a time capsule that is contained within the Lagios 1 satellite, which is expected to remain in orbit for 8 million years. So even if the surface of Earth was to be decimated, that satellite would still hold the information about us for much longer. And something that would survive even longer than that are our geostationary satellites. Their orbit is more stable and they may stay out there for billions of years. Michael talks about these geostationary satellites as perhaps being our pyramids, in terms of being the thing that a future potentially alien civilization would find and use as a symbol to represent us. And I love this part of the video where he points out that pyramids were a kind of tomb, and that when a geostationary satellite is no longer useful, we push it out of the way a bit into something called a graveyard orbit, where it will remain in its own kind of tomb, but it's a tomb for a satellite rather than for a human body. And then the video of course discusses ways that our traces have already gone outside of the solar system, with things like the Voyager Golden Record and the Pioneer plaques. And that in and of itself is a really inspiring video. But then, appended onto that, seemingly randomly but quite smoothly, is a discussion about this idea of the Library of Babel. And ever since I watched this video in 2015, I haven't been able to get this idea out of my head. It pops up every now and again as a thought whenever something crazy happens in life. This Library of Babel idea is essentially a website that stores chunks of text. Each page is 3,200 characters, but the thing is that it stores every every single possible combination of those 3,200 characters. So most of the pages seem like just random symbols, but actually buried away in the pages is descriptions of everything that has ever happened and everything that ever will happen. You can type in the craziest thing that's ever happened in your life and find the page number that was already written down on before it happened. I do believe Michael says in the video that there are more pages on this website than there are atoms in the universe, so maybe to you it will seem like nothing, but to me this idea is so captivating. And so I encourage you to check out not just Messages for the Future, but all of these videos that I've mentioned. I've put them all in a playlist and that link will be down in the description. A big thank you to my Patreon supporters for making these videos possible, and a special shout out to today's Patreon cat of the day, Penelope.